Now let's talk a little bit about the transformations of radical functions. And when I say transformation, what I'm talking about is how you can manipulate the shape and the look of a radical function. For instance, this is a radical function. What do I have to do to the equation of this radical function to make it go up? Or what do I have to do to the equation of the function to make it go down? Or what do I have to do to it to make it go to the right or the left? What do I have to do to it to stretch it out or make it really skinny? What do I have to do to it to flip it, which I can, I guess, do on this? Wait, I can. So check this out. Flip. Left to right. See? What do I have to do to flip it? All those things. What do you have to do? Okay? Well, there is a general formula for radical functions. This is it right here. How I say this is y is equal to a. The a represents a number. It does something to it. Times the square root of b, which also does something to a radical function, times x minus h plus k. Okay? So let's use this. And we're going to fill in what the a does, the b does, the h does, and the k does. And let's just figure out what it does by playing around with a radical function a little bit. So I'm going to go to Desmos. This is my Desmos website. And what I have here is there's two functions graphed. Actually, I don't like this. I'm going to go to the one I fixed up. Here we go. There's two functions graphed. There's an orange function graphed, and then there's a red function graphed. And what we're going to do is we're going to try to figure out what each of these functions, what happens when I manipulate from the parent function being the orange function with the red function. And notice this third line down, there's an a, and a equals 1. And so I'm going to manipulate it, and we're going to see what happens to the a when we manipulate it. And so we're looking, and it looks like as I manipulate this a, it looks like it gets wider or as when it gets bigger. And when it's less than 1, it's getting a little skinny. And when it becomes negative, it flips to the bottom side. It flips upside down, right, when it becomes negative. So it looks like those are some traits that we can put in for the a. So if we go back to our notes, this is what the a is actually doing. It's doing a vertical stretch or compression, right? Stretching it really vertically or compressing it down. For when a is less than 0, the graph is reflected over across the x-axis. That's why it flips upside down when it goes over the x-axis. That's what's going on when it's negative. So that's kind of what the a does. Let's go back and see what some of these other things do. Let's start playing around with this b a little bit. See what the b does on the inside there. Well, the b, it looks like it's doing kind of the same thing. Oh, so the b kind of stretches it too a little bit. I don't know what's going on, but it does flip it over the x-axis when it's negative. When it's negative, it flips it over the y-axis. Oh, that's weird. Okay, when I play around with that. Okay, well, let's see if we can summarize this. The b, what it's doing is doing a horizontal stretch, stretching it horizontally instead of vertically like the a does by a compression factor of 1 over b. And whenever b is less than 0, the graph is being reflected across the y-axis and stretching a little bit more. So that seems to be what the b does. Okay, let's take a look, see what this h here, what this does to the function. Okay, so we'll go back to that graph, and we'll make it look a little bit more normal. And we'll just start playing around with this h here. So we're taking the h, we're moving it back and forth. Oh, looks like the h makes it go left and right. And when the h is positive, it goes to the left. And when the h is negative, it goes to the right. Okay, that's good to know. Let's put that in our notes right here in this section. A horizontal translation of h units to the right for when h is greater than 0. Okay, you can write this different than how I have it here. And when the absolute value of h units to the left for when h is less than 0. So when h is, pretty much what it's saying, when h is less than 0, it's moving to the right. And when h is greater than 0, it's moving to the left. Or actually, when h is greater than 0, it's moving to the right. And when h is less than 0, it's moving to the left. But that would mean if you put an h that is positive in here, it makes it look like it's negative because you got this negative sign. So whenever it looks negative there, remember, when it's negative, it's going to the right. When it's positive, it's going to the left. Okay? And lastly, let's figure out what this k does. We'll play around with this k a little bit. K, oh, look at what the k does. Goes up and down, up and down. So it looks like when a k is positive, it goes up. And when k is negative, it goes down. K is positive up, k is negative, goes down. Positive up, negative down. Okay, let's put that in there. And this is what I have in this bubble. A vertical translation, okay, that's translation is moving up and down or moving around, of k units up for k greater than 0, and when k is going down when k is less than 0. So that's what k does. And so this is how you can transform a radical function around by using this formula, by just changing your a, which does the vertical stretch and flip over the x-axis, by changing your b, which does a horizontal stretch and flip over the y-axis, by changing your H, which does translation left and right, or the K, which does a translation or moving up and down.